Hi guys, so here's an honors topic for Algebra 2. This is one that I've discussed with you that we're going to be doing in Chapter 3, but not one I've quite really given you a video for yet. So this is going to be simplifying roots that are higher than a square root. So we're talking about simplifying a cube root, simplifying a fourth root, maybe even simplifying some fifth roots. So what I have on the board is all of the perfect cubes, perfect fourth roots, and perfect fifth roots that you basically attain by taking 2 cubed, 2 to the fourth, 2 to the fifth, right? And then you can't see the glare here, but there's a 3 to the third, 3 to the fourth, 3 to the fifth, and 4 to the third, 4 to the fourth, 4 to the fifth, and so on. So I only went up to these 7. So basically this would be 7 times 7 times 7 equals this. 7 4 times would be this. 7 5 times would be that number. As you can see, we're already getting to really large numbers, so I didn't want to keep going because I'm not going to ever give you numbers that big. So as a review, if I asked you to find or simplify the square root of 12, what I would have had you done was find all of the factors of 12. The factors would be 1 and 12, 2 and 6, 3 and 4. And then you would have said, okay, out of all these numbers, are any of these a perfect square? Meaning I can take the square root and I'll get a whole number out of it. 4 would be the only one. So you would have split this up between the square root of 4 times the square root of 3, and then simplified it. Square root of 4 is 2. So you would have had 2 root 3 as the answer for that one. So notice the 2 examples I have for us to do for sure here is the cube root of 128 and the fourth root of 768. So I don't know about you, but I don't really want to waste my time finding all the factors of 128, much less finding all the factors of 768, right? That factors list is going to be massive. With this style of simplifying, that finding the factors works perfect. As soon as we start trying to simplify much larger roots, it's just not going to be in our best interest to find all the factors, okay? Instead, what we're going to do here is we take the number you are given. So in this case, it's 128. And it's a cube root of 128 that we have to simplify. So instead of saying, well, what are all the factors of 128? There are very few numbers that have a whole number cube root, especially that are like under 100, okay? So if you took 2 cubed, that gives you 8. If you took 3 cubed, that gives you 27. 4 cubed gives you 64. 5 cubed gives you 125. So already I only have 4 possible factors that would work of 128. So again, I'm not going to find all the factors. Instead, what I want you to do is say, well, let's see, is 128 divisible by 8? Meaning if you took 128 and tried to divide it by 8, would you get a whole number? So let's do that. Let's take 128 divided by 8. You do. You get 16. But 16 is still a relatively large number. So I don't want to stop there. I want to keep going. So let's say, well, what about 128 divided by 27? 128 divided by 27, that's a decimal. So that one's out. 128 divided by 64 is 2. Okay, so I have 2 different options, I'm sorry. 128 also will not be divisible by 125. So 128 was not divisible by 27, so 27 is out. But I do have 2 different factors. I have 8 and 16 and 64 and 2. Either of these factors would work. One, however, will be a little bit more work than the other. If I chose 8 and 16, either of those numbers in and of themselves are both relatively large numbers. Like given 16, I would be able to simplify the cube root of 16 again. However, after taking the cube root of 64, I won't be able to simplify the cube root of 2 any further. So I'm going to use this factor set. So it will be now the cube root of 64 times the cube root of 2. Okay, the cube root of 64 is 4. And now we're just times the cube root of 2. And that would be your final answer for that one. Okay, so let's move on to the next example. Again, the reason we did not find factors was because there are many, many, many factors of 128, but there's only very specific numbers that actually have, that are a perfect cube under the 128. So now we're going to look at specifically just fourth roots. So these are all even whole number fourth roots. So we have trying to find what number goes into 768. That would be a perfect fourth root. So we have 16, 18, 256, and 625. I'm going to stop at 256 because I already know that 625 is not going to go into 768 as a whole number, right? If it's over half its size, it's not going to go into it evenly and wholly. So we are going to take 768 and divide it by 16 and see what we get. We get 48. So essentially 16 times 48 gives us 768. So that's one factor we found. Now we're going to do 768 divided by 243. That gives us a decimal. So that one is out, not going to work. I skipped one. I skipped 81. Oh, I jumped over to this one. That's why. So backtrack a second. 243 is not an even, or is not a perfect fourth root. That was a perfect fifth root. I went over to the wrong list. So we're at 81 right now. 768 divided by 81. That's a decimal though. So 81 is out. 768 divided by 256. Now let's see what we get there. That is 3. So now we have two different factors to choose from. 16 and 48 is one of them, and 256 and 3 is the other. So 256 and 16 are both the perfect fourth roots. So I want to look at 48 and 3. Which one of these would be my better choice? 48 has a huge possibility of still being able to be simplified down even further. In fact, it absolutely will be able to be simplified down further. So if I chose this top factor, I would have to do 2 simplification stages. If I chose the bottom one, I only have to do 1. So we're going to choose 256 and 3. So the fourth root of 256 and the fourth root of 3. So we know the fourth root of 256 is 4. So we can replace that with 4. And again, we do not have a whole number fourth root of 3. So that would be my final answer. Okay, if you still want to do some more practicing of this or you want some more videos, let me know and I can get you more videos of this. But this is basically the overall method that you'll use to simplify down roots that are higher than a square root.